Section 7.2 is properties of graphs of quadratic functions. There's basically two methods of how to graph. We've already seen how to graph using the calculator. I'm going to keep going over this again though so that you totally understand how to do it with the calculator. The first way, and this is the way we used to do them in, well, partly, this is the way we used to do them in school, was by a table of values. So they work just like the same way you've always done with the x and the y. You should have been, these should look familiar from grade 9 and from grade 10 as well. And you pick values of x that work well in the equation. I picked values of x 4, or -4, -2, 0, 2, and 4 because I have this half value in front. I'm going to pick values that when I square them I can easily divide by 2. So I've picked values that are multiples of 2. So for the first one, you plug a -4 in. -4 squared is 16, positive 16, divided by 2, 8. 8 minus 7 is 6. The next one I have is -2 squared is 4, positive 4 divided by 2 is 2, minus 1 is 1. 0 times that is 0, minus 1 is -1. 2 squared is going to be 4 again, divided by 2 is 2, minus 1 is 1. And you can kind of guess what the one for 4 is going to be, 16, 8. So, oh wait a second, 16, what did I do? I did the first one wrong. Nobody told me. So 16 divided by 2 is 8, minus 1 is 7, not 6. And this one's going to be 7 as well. 4 squared is 16, divided by 2 is 8, minus 1 is 7. Okay, so I have my table of values here. Now I can plot all these points. My first one is -4, comma 7. So I have -1, 2, 3. Let's make each one of these worth 2. 2, -4, -6, -8. And that's going to be -2. Just because it works better if I have a small space, right? And 2, 4, 6, 8. Sometimes it's good to change the values of the scale anyways. So -4 is back here, and 7 is going to be halfway in between, which is right there. -2 is right there, and up 1 is halfway in between, which is there. 0, -1 is right there. 2, comma 1, and then 4, comma 7. So 4, comma 7. And remember what I said last lesson about symmetry, right? These parabolas are always going to have some type of symmetry. So they're going to look the same if you cut them down the middle. Okay, so there's my parabola. Connect all your points. You know what the parabola is going to look like because it's a quadratic function, because it's got the x squared to it. You know it's going to have the parabolic shape, and therefore you know to connect the dots in a curved manner. Okay, the second way to graph is by using your calculator. So if we bring up the calculator, remember to use the y equals button. Clear whatever you have there. And then I have -3/2, so negative, and I'm going to put that in brackets. -3/2 x squared plus 3. The good thing about the TI-83 and most calculators, when you use the squared button, it's done, and then you can just go on to plus 3. Next thing you do is you have to graph it, so I click the graph button. Let's make sure our window is okay. Yeah, looks fine. So I graph it. Looks like an upside down. It goes through at about 3. So 1, 2, 3. And then it goes through a little bit more than -1 and 1. So probably to about there and there. And your graph goes down and down like that. Okay. So that's graphing using a calculator. Basically graphing it, making sure your window looks the same. Sometimes what they want you to do is they have a y1 equals and a box, and in that box you would put this function here. You would just put the value of that function. Y equals what you put in the calculator. Okay, how to interpret graphs of parabolas. So we've graphed them. Now we have to look at, okay, well we know what the axis of symmetry is. For the red one, if I'm looking at the axis of symmetry, it's where it cuts it straight in half, right? So a dotted line would cut this graph right there. And what it wants is, what is the x value? X equals what? Well, x equals 1, 2. My value for x is x equals 2, and for the value of x equals 2, that's where it cuts the graph in half. Where's the vertex? Well, the vertex is actually that bottom point. The vertex is right here. And where is the vertex located? Well, we actually want a point this time. So it's at 2, -1. 2, -1. That's where the vertex is located. The domain, remember, is all the possible x values. And for parabolas, because they go off in each direction to the left and the right forever, the x values are an element of all the real numbers. There's no restrictions on them. For the range is going to change depending on if it's shaped upside or right side up or upside down. So the range for this one, well, I know that it keeps on going up and up and up forever. So I know it's going to be y bigger than or equal to, but what's my smallest value for my y? What's the smallest value? Well, the smallest value is where the vertex is, and it's where the y value is. So it's actually at -1, and anything bigger than -1. So y is bigger than or equal to -1. So that's for the red graph. Now let's do the green graph. So same stuff, same bunch of information. We want to first of all figure out what the axis of symmetry is. So where does it cut the graph in half? Well, it cuts it in 1, 2, at -3. But what value? X. X equals -3. That's the axis of symmetry. The vertex, remember, is going to be a point. So it's an x comma y point. And the vertex is the point way up there where the graph kind of comes to a point, or comes to a head. So where is that point? Well, it's at -3, comma, 2. The domain, for all parabolas, it's always the same, unless they're shaped, I don't think you deal with those though, unless they're shaped left to right, like that. You can have parabolas that are shaped like this, in which case your domain is bigger than that, your vertex point, but I don't think you see those in grade 11. So for this one, your domain, again, x is an element of all real numbers. It's anything. Your range, now this time I know that it's everything, it keeps on going down and down, down forever. So it's going to be y less than or equal to. And what's that top point? Well, it's just 2, right? Because it's just the y value of my vertex point. So I've shown you how to find the axis of symmetry, just cutting the graph in half and seeing where that axis lies. The vertex is where that point is, where the graph kind of starts. And the domain, always all real numbers, and the range is either bigger than or less than, depending on if you have a minimum point or a maximum point. All right, let's go on to our final example. The height of a ball can be modeled by the equation y equals -3.8x squared plus 15x. What is the maximum height of the ball? When does it occur if x is the number of seconds after the ball is hit? So here I have my window. It goes from -10 to 10 on both axes. I need the maximum height. First of all, I need to graph. So I bring up my graphing calculator. This type of question you would definitely not do with a table of values because it's too hard. So I have -3.8x squared plus 15x. Make sure my window settings are correct. Yep, -10 to 10. Basically -10 to 10 again. So I graph it. Uh-oh, it's off my window. So I'm going to have to change my window or either zoom. A good thing to do sometimes is to go zoom, let me see, down, 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 down. Zoom fit. It should try to fit the entire graph in. It'll, these little lines on the side so that it's loading. Well, that's still not that great. So let's change this x minimum. -10 was okay. 10 was okay. Now my y minimum, let's change that to, what was it before, -10. Let's change my y maximum to say like 20 or something. Let's see what that looks like now. Okay, that gives me a better idea of what the graph looks like. So I need to figure out, so first of all I kind of sketch a picture of my graph. I'm going to have to change my window settings, right? Because now my window is going up to a maximum of 20. So let's just change those. It's still going from -10, but now this time it's going up to 20. So let's say it's 5, 10, 15, 20. Just so I have a semi-accurate picture of what the graph looks like. And it goes up to maybe about, well, I'm not quite sure yet. So let's calculate this. The way to calculate this is I go second function, calculate, And I want to calculate the maximum. So I go down to maximum, and I hit enter. Then it brings up this question, left bound? Left bound means to the right of your maximum. So I know the maximum point is up at the top. To the left of it, I can just move my cursor, right? You can see you can move your cursor around. And I move my cursor so that it's just to the left of that top point. It doesn't matter if it's like right to the left or just a lot to the left, as long as it's to the left. So there, that's a good place. So I press enter. Then it comes up right bound. So that means I have to go to the right of the maximum point. So I move my cursor, move, 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 so that it's at least to the right somewhere of the top point. It doesn't matter where, as long as you go over the top point and then to the right. Hit enter, and then it says guess. It's actually going to solve it for us. And down at the bottom here it tells us what the maximum value of x is, or where it occurs on the x-axis, and what the maximum value is. So it's about 14.8, almost 15. It occurs at almost 2, so I'm going to put my point about there. And my graph goes through the axis and then goes through. Now, how do I figure out those points? So I know my maximum value is 14.8. It occurs when my x value is 1.97. Yeah, 1.97 seconds, and this is measured in, should be measured in meters. It's really, really high. Okay. Now, my x value is 1.97, which means it cuts through on my axis at 1.97. So if I put my axis of symmetry down, my axis of symmetry is going to be x equals 1.97. Remember, it's basically your maximum minimum value and where the x value of that, or where it occurs on the x-axis. Now, do I know that it cuts through at 5? Well, not really. And my last question here, how long was the ball in the air? We have to know exactly where it cuts through. So we have to calculate something else. So the next thing I want to do is I want to go second function, calculate, and I actually want to calculate the zeros. The 0 is where it crosses on the x-axis. So let's check here. And then again, it brings me up this left bound thing. Well, I have a place where it crosses the x-axis down here. Let's see. Let's see where that is. So I put it to the left of that point where I know it crosses the x-axis. Make sure it's to the left. I press enter. Then it says right bound. Right bound, I'm going to have to go to the right. To the right of that point is over here. Hit enter. Then it says guess again. So it does cross through the point at 0, 0, which I kind of had on my graph here. Crosses through the point right in the origin. Now I have one more 0, the one over there I have to calculate. So again, second, calculate. I want to calculate the zeros. This time I have to go to the left of my other 0. So notice I'm moving the cursor. Oh, that was too far, right? I want to be to the left of the 0, so I have to make sure that it's to the left. So I press enter. Then I go to the right of the 0, so I go right. Oh, there we go. Good. It's below and to the right. Now, don't get stuck in below and above, because it's not necessarily always going to be below to the right, because if your parabola is shaped the other way, it's going to be different. So I have that one there. Guess. Comes up with an answer of 3.9. So I was pretty close to with my estimate of what it was going to look like here. So 3.94. 3.95. So how long was it in the air? Well, it's in the air from there all the way to 3.95. Close. It should be actually over here, I guess. Let's change our graph here. So it's going to go down through the axis. It's going to go down. It's going to go up to the maximum point there. It's going to come down. It's terrible. So it's going to be 3.9, what was it? 3.95. So how long was the ball in the air? Well, it was in the air from here all the way to here. And then it's not in the air anymore. So it's actually 3.95 seconds it was in the air for. Now, does it make sense to go below the axis? Not really. In this case, I probably wouldn't even want these values below. I would actually get rid of them and just say my graph goes from the top to the bottom and from the top to the bottom. And it would stop. Or it would probably bounce again or something like that. But in this case, if you were looking at domain and range, your domain would would have to make sense in terms of your graph, and your range would have to make sense in terms of the graph as well. So that's how to graph on your graphing calculator and calculate different values.